Every single day, you and I, we send billions of messages without a second thought, right? A text, a quick search, a video call. But have you ever actually stopped to think about what's happening behind the screen? Well, today we're going to dive deep and uncover the real story of how the internet actually works.
So let's start with a really basic question. When you hit send, where does your data actually go? I mean, physically. It feels like it just poofs into the cloud, doesn't it? But the reality? Well, it's way more physical and honestly, a lot more amazing than that.
And here is the first big surprise. The internet, it's not floating up in the clouds. It's not bouncing off satellites. Nope. Around 99% of all international data, it's traveling through physical cables. Cables that are buried deep, deep down at the bottom of the ocean. Yeah, you heard that right, 99%.
So right off the bat, we need to completely ditch that idea of some fluffy, weightless cloud. A much, much better way to picture the internet is to think of it like a giant global nervous system. A very real, physical network of cables and computers that connects literally all of us.
All right, so first up, let's talk about the actual hardware. The nuts and bolts of this global system. We're talking about those deep-sea cables and the absolutely massive buildings they all plug into. And the scale of this thing, it's just staggering. We're looking at over 1.4 million kilometers of submarine fiber-optic cables crisscrossing the ocean floor. Now, to put that into perspective for you, that's enough cable to wrap around the entire Earth almost 40 times. Just wow.
Okay, and get this, because this is a really mind-bending fact. These cables are carrying trillions of dollars in financial transactions, endless Netflix streams, all our messages, and yet most of these incredibly vital cables are only about as thick as a garden hose. It is just an unbelievable feat of engineering when you think about it.
So all these undersea cables, where do they lead? Well, they plug into things called data centers. And you gotta forget any image you have of some dusty little room full of computers. No. These are colossal warehouses. Some of them are the size of multiple football fields. They are quite literally the beating heart of the internet.
Keeping the internet on takes a monumental effort. These places run 24/7, 365 days a year. The climate inside is perfectly controlled. The air is meticulously filtered. They've got massive backup generators. Every single email you've ever sent, every photo, every show you stream on Netflix, it all lives on servers inside these buildings. And get this, together they chew up about 1% of all the electricity on the planet. That's more than many entire countries use in a year.
Okay, so that's the hardware, but what actually happens moment to moment when you just click a link? Let's follow one single click and see exactly how your information zips through this whole global system.
Well, it all starts with something called a packet. See, your device doesn't just send your message out in one big chunk. Instead, it chops it up into thousands of tiny little pieces. The best way to think about it is like each packet is a tiny digital envelope, and each one has a little address label on it telling it exactly where to go.
And from that point on, each of those little packets goes on its own epic journey. It zips from your device to your router, then jumps onto your internet provider's network, and from there it's launched onto these massive fiber-optic highways we call the internet backbone. It might have to cross oceans, pass through a dozen different networks, and then, at the very end, all those thousands of packets have to be perfectly reassembled in the right order at their final destination.
And the truly amazing part? The speed. This whole incredibly complex journey, spanning continents and oceans, often takes less than 1/10 of a second. It all happens so fast, it just feels instantaneous, doesn't it?
So, with trillions of these packets flying around the globe every second, how does it not all just descend into complete chaos? Well, that's where the invisible logic comes into play. These are the protocols that basically act as the internet's air traffic controllers.
See, unlike an old-school phone call that needed a single, dedicated line from point A to point B, the internet is decentralized. It's much more like a smart highway system, where every single packet can find its own best route. So if one road is jammed up with traffic, or maybe a cable gets damaged, your data just finds another way to get there. It's what makes the whole system so brilliantly resilient.
Now, the system that manages all of this traffic is called the Border Gateway Protocol, or BGP. And really, the best way to think of BGP is as the GPS for the internet. It's constantly getting updates from thousands of different networks about traffic jams, slowdowns, and outages, and it uses all that info to create this live, dynamic map of the internet, making sure your data is always taking the fastest, most efficient route available in that exact moment.
But wait, how do all these different networks, which are often competitors, cooperate with each other? Well, they meet up at places called Internet Exchange Points, or IXPs, and these are actual physical locations. Think of them like massive digital crossroads, where hundreds of different networks, like say AT&T and Verizon, literally plug their systems into each other to exchange traffic directly. It's this direct interconnection that makes the Internet a truly global network.
Okay, we're almost there. But there is one last crucial piece to this puzzle. See, computers don't really understand names. They communicate using long strings of numbers called IP addresses. So how in the world does your browser find google.com when there are billions of websites out there?
The answer is something called the Domain Name System, or DNS, and you can just think of it as the phone book for the Internet. It's this huge distributed database that does one simple vital job. It translates the human-friendly names we type, like google.com, into the numerical IP addresses that computers actually need to communicate. I mean, without DNS, we'd all have to memorize long strings of numbers for every single site we wanted to visit. Can you imagine?
So, when you put all of these pieces together, what do you get? Well, when you combine this incredible physical infrastructure with all of this invisible logical programming, the result is something, well, pretty miraculous.
You have submarine cables, you have these massive data centers, and you have these brilliant routing protocols, and they all just work together, seamlessly. But you know what the most remarkable part of it all is? There's no single owner. No one company, no single government controls the Internet. It's a truly collaborative system, built and maintained by thousands of completely different organizations all working together.
And that's why this globe-spanning network, built on this incredible foundation of cooperation between competitors and even entire nations, is truly one of humanity's greatest collaborative achievements.
So, I'll leave you with this one last thought. The next time you send a message or tap on a link, just for a second, picture that incredible physical journey it's about to take. Imagine a tiny pulse of light flashing through a cable the size of a garden hose, buried deep under the ocean, traveling at nearly the speed of light, all just for you. It's really, truly more amazing than we ever stopped to realize.